Hello everyone. So this video tutorial series is primarily based upon that Arduino based projects. As you know that the Arduino is extremely popular microcontroller among the students, hobbyists for designing very interesting electronics projects at low cost. So this is a low cost solution and you can easily implement different types of interesting projects by using Arduino. But before designing the circuits in hardware, it is recommended that you should use a simulation platform to design your circuit, because sometimes what will happen that if your connection is wrong, okay, that whatever the pins, input output pins of hardware, okay, if the short circuit takes place, the pins might be damaged permanently. Okay. So that's why it is recommended that you first go for a simulation, and also you can check the correctness of the logic of the circuit you are going to implement through a simulation environment. Now, TinkerCAD provides a virtual platform to simulate Arduino-based projects. So here you will get lots of different sensors, so you can explore, decide the different types of sensors are there. So starting from ultrasonic sensor, the phototransistors, PIR sensor, temperature sensor, tilt sensor, gas sensor, okay, and those are sufficient to design any types of electronics projects. And after simulating the circuit, whatever the code we have, you can directly export that code to Arduino IDE. You can compile, that is basically the C code. You can compile and you can implement your original hardware as per the same diagram, and quickly you can develop your projects. So let us see how to start with this one, how to design, how to simulate the circuits by using this Arduino controller. As you know that Arduino is basically based upon the ATmega chip. Here, this chip is basically ATmega 328. So it is 8-bit microcontroller. And talking about the board, you can see, so A0 to A5, total 6 analog inputs are there. That means simultaneously you can connect 6 different sensors at the input, analog sensors. And also those are the input output pins you can check, okay, starting from B0 to B13. This virtual TinkerCAD platform is very useful, especially for the beginners, those who wanted to start their project in this Arduino. And later you will see we can easily implement the code without having any prior experience how to write the code, etc. So let us see. So the first project I'm going to implement, that is how to interface one LED. That means we are going to blink one LED a particular time interval. So for that, first we have to drag the required components here. So I'm taking an Arduino board, so you can see it is here. Just check, you can drag it here. Okay, it will be in your workspace. Okay. Then to design the circuit, we need a breadboard. So there are various types of various size of breadboards are available. So you can check it. Just check here, breadboard small, breadboard mini. I'm going to take this. It's very small one, and that is sufficient for this project. Then I need one resistor, because you cannot connect that LED directly with the 5-volt and that output pin of controller. Okay, so you have to limit the current, otherwise the pin may be damaged. Okay, you have to do the same when you are going to implement it in the hardware, original hardware. So always connect that LED using a register, you can take the value of register like 220 kilo ohm or 220 ohm or simple 100 ohm. Or you can take 220 ohm. It is recommended that you should take 220 ohm resistance. This is. Now you can place the LED. Okay. This one is the LED. Now just check the pin. This is cathode and this one is anode. Okay. So you can configure it, that is depending upon the output you are supplying, whether you will give logic 0 to activate the LED or logic 1 to activate the LED. So you can configure it. So I'm going to connect the register here at the cathode terminal, and now this one will be connected to the negative terminal. See here, we have a ground pin here, so you can connect it. So in other terminal, that is in anode terminal, we are going to apply the input. Okay, so later the input I am taking from D1, so you can check it's a D1. I'm going to apply the input here. It's this one. Now our circuit is complete. Now it's time to program it. So go to the code section here. So here you can write the code in two different ways. If you are familiar with the C code, then you can directly go to that part, the text, and you can develop the code. Okay. But if you are a learner, you do not have idea to how to write the code for this, so better you can use this block. So here we are going to toggle one LED. That means LED will be on for a specific time period. Then again it will be off. Again it will be on, and this will run for infinite time. Okay. So what we can do? So we are taking one pin. Okay, that means the pin 1 basically. So we are taking this block, set pin, change the pin number. So this is our pin 1 because I am using pin 1 here. So if you are connecting the LED here, pin 0 or any other pin, so you have to change the pin number accordingly. Okay. So first what we are doing, we are sending a logic 1 to switch on the LED. Then we have to give some delay. So go to the control. Okay. See here, wait. Wait means it is a delay. How much delay I'm giving? So this LED will be on for 1 second. Now again, I have to send a logic 0 at the output. So pin number is 1, and I'm sending a logic 0. Okay, I send a logic 0 at the output, that is this one, and now again I have to give some delay. This. So this is our set pin to high, wait for some time, that is 1 second, so you can change it, and set pin to low, again wait for some time. Okay, that is 1 second, and this will continue for infinite time. Now you can visualize what will be the corresponding code. Now see, TinkerCAD automatically converted to corresponding C++ code, so you can check. We are having two sections here. One is void setup, another one is void loop. In the void setup section, the configurations generally is performed. So pin mode 1, output, that means we are going to configure pin 1 as output pin. Okay, because we are sending some data to the output side peripheral, that is LED. Now void loop is basically infinite loop. In almost all microcontroller, that one infinite loop is required. So by using this function, this is equivalent to, you can say, that one infinite loop in C programming. So digital write 1, high, that indicates we are sending a 1, logic 1. The high means logic 1 at the pin number 1. Okay, and then we are giving some delay, that's 1000 millisecond. Here the unit is in millisecond. Then again, we are sending a logic 0, that is low, at pin 1, and again we are giving a delay of this one. So this is our code. So now we can test it. I just run. Yeah, now check. The LED is blinking. It's on and off, okay, and the interval is around 1 second. So we can stop simulation and we can change this time interval. Let the LED is on for 3 seconds and LED is off for 1 second. So we can do that easily. Let us see. So for 3 seconds, LED will be on. For 1 second, it will be off. Again, for 3 seconds, it is on. For 1 second, it will be off. So similarly, you can change this pin number 1 to pin any other pin here. Okay, and you change that here accordingly, and it will work. Okay, and if you just see the code, so this is the code. See, when I am changing it to 3, it is automatically changes to 3000. So as a beginner, you can use those blocks, but for a little bit complex project, so it's better to start writing this code. You cannot use this block because this block's having some limitations. In all cases, you cannot use this one, those blocks. So this is our very first program, which is very easy. Now let us see another one program. We are going to read some sensor value. For example, I'm connecting one potentiometer. Okay, so delete that LED. So what we are doing, we are going to read the potentiometer value. Okay, so you check the potentiometer. There's 2 terminal will be connected to, one is connected to ground, another one is connected to the VDD. This one I am connecting it to VDD, that is 5 volt. This, and the middle one, it is the output. So I am connecting it to one analog channel. So this one will be connected to the analog input, that is input of ADC. Let A0 channel I'm using. This. So then if I rotate this knob, that means this output, okay, that the wiper, this value will vary in between 0 volt and 5 volt. So we are applying that to the input of one AD converter, built-in ADC, and the pin A0, and the controller will convert that, and it will display the value into the serial port. Also, you can display it through a LCD or any other display device. Just for simplicity here, we are going to use a serial port. So this is our configuration, okay, hardware configuration. So how to write the code. So here we are going to use the code for it. Okay. So text. Okay. So we have 2 sections. One is void setup section, another one is void loop section. Okay. So the first of all, we are going to define some variable, so which will be used in this program. So before void setup, let int sensor equal to A0. That means we are using the A0 channel. Okay. Then that converted digital value, after conversion, the digital value will be loaded to some variable. And digital value, so initially 0. Okay. Then also we can read, that means how much voltage we are applying from potentiometer. We can convert that digital value into its corresponding analog value. So what we can do, we are taking one value float type analog value equals to 0.0. Okay. Then we have a setup section. Now we are going to print the result in the serial terminal. So first we have to initialize the serial terminal. How we can do that? Serial.begin. Then you have to specify the baud rate. Let 9600. Serial.begin 9600. Now see, TinkerCAD by default gave some delay. This saying that delay a little bit to improve the simulation performance. I'm not going to change it, but if you are going to implement the same project in hardware, so you can change it. The next line, see, our first job is to read the analog voltage which I'm applying to the pin A0. Okay, so and the corresponding converted digital value will be saved into this variable digital value equals to. Now see, the function analog read basically read the content of ADC. Okay, read the content of ADC. That means whatever the signal we are applying, okay, it will read that, and we are applying at what sensor. That is basically A0. Also, you can directly write A0 here. So the converted digital value will be stored inside this. Now remember that the ADC here, it is present, the internal ADC is having a resolution of 10 bit. That means the maximum count you will get is 2 to the power 10. So if you want to calculate the scale factor, or that is the how much analog voltage required to change the ADC value by 1 bit, so it is basically, you can calculate. So 2 to the power 10 means 1024. That means total 1023 steps are there. Okay, so step size is 1023. So corresponding analog value will be, now see that total 1023 represent how much voltage? 5 volt. That means if the input is 5 volt, the output will be 1023. That means 1111, total 10, 1 will come at the output. Okay, and its decimal equivalent is 10, okay, 0 to 1023. Okay, so analog value will be how much? That is digital value into the step size. So 5 volt represent total 1023 steps. Okay, so each steps represent 5 divided by 1023. That is basically scale factor. So 5 divided by 1023, that is the value of 1 bit increment into total digital value, this one. So the converted analog value will be stored here. So that means we are just converting the digital value to its corresponding analog value, and now we are going to display it over serial terminal. Okay. Then what we can do to print any this character in the serial terminal, we have a command serial.print. Okay. That analog value is. Okay. So we are using the line analog value is, then we are going to print the value serial.print line, and within this we are going to send the data, that is analog value, this one. Okay, this one. Now we already sent the data to this, and now we have to give some delay before reading the next one, next data, next sensor data. Later I'm giving a delay of 1 second, later I'm giving a delay of 3 seconds. Okay, so this is our program. So let's run this. Okay, now see, the result will be plotted in serial monitor. So you can open the serial monitor here. Now check the analog value for every 3 seconds, the result is displayed, analog value is 0. So why 0? Because I'm not changing its position. Now if I change, now see the analog value is 3. Now I'm changing it approximately mid position. Okay, so it should be around 2.5. Okay, so around 2 volt. So 1, 3, 4, and check the maximum. It is 5. So in this way, we can interface one sensor. So you can connect one real sensor in place of this potentiometer, which will be directly connected to any one of the analog pin. Also, you can use multiple sensor, and you can connect multiple sensor that you see you have a option to connect total 6 analog sensors at a time. So you can do that. So today up to this, in next tutorial, I will show you how to display this result. That means whatever the result we are getting in serial monitor, how to display this result in a liquid crystal display, that is LCD. Okay.